So, the efficiency of algorithms. It says, understand that more than one algorithm can be used to solve the same problem. Now, that's fairly straightforward. I've just brought up an example here. Last time, or a few times ago, we had this example of an algorithm to solve a factorial, and we use this little trace table to show that it eventually hits 120. Here, I've written an alternative algorithm that works fairly differently. This one works down, this one counts up until it gets to the limit, and it also increments before it does the maths, and obviously it still finds the same answer, even though it does it in a fairly different way. And in a lot of more complicated situations, many different algorithms could possibly produce the same answer. For example, it's technically possible that two completely different chess playing algorithms both say that the same move is the right idea. Just because the results are the same does not mean that the algorithms are the same. In the same way that if you took two students and they both happened to get 87 marks out of 100 on a test, they're not the same student just because they got the same mark. Multiple algorithms can produce the same result. It's what we would technically call a many-to-one mapping, not a one-to-one mapping. Many different algorithms can produce the same result, and so there is more than one algorithm that can be used to solve the same problem. And then it says, compare the efficiency of algorithms, explaining how some algorithms are more efficient than others in solving the same problem. Now this, initially I thought this was quite complicated, but it says formal comparisons of algorithmic efficiency are not required. If you do Googling around this and you hear people talking about something called big O notation, click away because you don't need to know it. That's more complicated. It says exam questions in this area will only refer to time efficiency. All that's going to be, I think, is somebody saying, I have algorithm A and algorithm B, and perhaps it will say algorithm A on 1,000 data points took, say, 60 seconds, and then it will say something like algorithm B on, maybe we only tested it on 500 data points and it took 45 seconds. Which one is a more efficient algorithm? Well, it looks like probably algorithm A, because we can assume that algorithm A would take about 500 on a 500 points. It would take about half that time. It might even be that they're really nice to you and they say on the same number of data points, this one took 45 seconds, and would say which one is more efficient. Well, it's clearly algorithm B because it did the data points faster. If you want to be a bit fancy, you can think a bit more like physics. If you think about physics, they say speed equals distance over time. You can use the same equation and sort of say the speed of the algorithm equals the number of data points it did divided by the number of seconds. So algorithm A can do 1,000 points in 60 seconds, which is whatever 1,000 over 60 is. And then algorithm B can do 1,000 points in 45 seconds. And so algorithm B is faster. Essentially, you can just say algorithm B is a more efficient algorithm because it can do the same task faster. It works faster with less resources. Technically speaking, you should compare things like the time it takes and the memory it takes, but in this, all we're interested in is how long does the algorithm take, and lower is better because an algorithm that works quickly is more useful.